Namaste everyone, this is Jyoti Manor Budhare from Sri Venkateshwara College of Engineering, pursuing Computer Science Engineering in 3rd semester from Bhaskara section. Today we will deal with the subject Data Structure and Application with the subject code BCS 304. Today we will discuss a research paper based on the data structure and application. So the name of topic I have chose for today's video is about data structure and algorithms and introduction. So up to now we know or we came from problem to program, but now we will see the algorithmic journey. The algorithmic journey starts with problem formulation. In that, the initial step involves understanding the problem clearly and defining the specific requirements. In the next step, the mathematical modeling. Once the problem is understood, it's crucial to model it using appropriate mathematical tools. The next one is algorithm design. With a clear mathematical model in place, we can design an algorithm to solve the problem. This involves choosing appropriate data structure and developing a sequence of instructions that will produce the desired output. The next one is program implementation. The algorithm is then translated into a computer program using a specific programming language. This step involves writing the code that effectively implement the algorithm's instruction. And the last one is testing and validation. Once the program is written, it's crucial to thoroughly test it with the various inputs to ensure its function correctly and produce accurate results. After knowing the journey of algorithms, we will come to the point, the foundation of computation. In that, it will include the three steps. In that, first one is finite sequence of instruction. Algorithms are defined as precise set of instructions that specify the steps needed to solve a problem. Each step must be executable in a finite amount of time. The next step is well-defined instructions. Each instruction within an algorithm must be unambiguous and clearly defined. This ensures that the algorithm can be executed consistently and produce the same output for the same input. In third step, finite termination. Algorithms are designed to terminate after a finite number of steps. This ensures that the algorithm will always produce a result in a reasonable amount of a time. Now we will go through the power of mathematical models. In that, first is graph theory. Graph theory provides powerful tools for modeling problems involving relationships between objects. For example, traffic light design can be modeled using graph where vertices represent turns and edges indicate potential conflicts between the turns. By analyzing the graph's properties, we can design optimal traffic light patterns. Second is set theory. Set theory is essential for modeling problems involving collection of elements. For instance, when dealing with a database of customer records, we can use sets to represent groups of customers based on the shared attributes. The last one is other mathematical tools. Then what are the other mathematical tools are available in that such as linear algebra, calculus and probability theory can also be used to model problems and develop efficient algorithms. Each mathematical tool provides unique perspective and framework for understanding complex problems. So our next topic is evaluating algorithm efficiency. Here we will discuss why we are using algorithms for typical performances. Now we will divide this analysis in three parts. Let's begin with the worst case analysis. Here worst case analysis focuses on the maximum amount of time or resources an algorithm might require for an input size. This approach ensures robustness and helps guarantee that the algorithm will perform acceptably even in the most challenging scenarios. The next one is average case analysis. Average case analysis considers the average amount of time or resources an algorithm needs overall possible inputs of a specific size. This analysis provides a more realistic estimate of algorithms' typical performance. And the last one is best case analysis. Best case analysis examines the minimum amount of time or resources an algorithm might require for an input size. This analysis is less practical in real-world scenario but can provide insight into the algorithm's potential for optimal performances. Coming to the next point, that is organizing data. We can organize the data by using abstract data types. It is also called entities. In that, it will include the four entities. First one is list, second one is set, third one is graph, and the last one is tree. We will see one by one. In that, first one is list. A linear sequence of elements where each element has a specific positions. Here we can operate the list using the insert, delete, search, access by index. If next one is set, an unordered collection of distinct elements where order and repetitions are not significant. That is called set. In this, we can operate insert, delete, search, membership test on the sets. The next one is graph, a collection of vertices or nodes connected by edges or relationships that represent connection between the objects. Here we can operate the graphs by add vertex, add edge, transfer search for paths. And the last one is tree, a hierarchical data structure where elements are organized in a tree-like structure with a root node, branches, and leaves. We can operate insert, delete, search, transfers, and finding minimum or maximum operation on the trees. Now here we will discuss a powerful tool in the data structure, that is recursive algorithms. Then what is recursive algorithm means? It is a problem solving technique in data structure and algorithms that break down a problem into a smaller sub-problems until they can be solved directly. The algorithm then combines the solution to the smaller sub-problems to get the solution to the original problem. In that, it will include or the recursive algorithms having self-references, base cases, and the recurrences relations. So, as exploring further advanced concepts in data structure and algorithms, it will provide a strong foundation for exploring advanced topics. As we go deeper into the field, we will encounter more complex algorithms and data structures such as dynamic programming, greedy algorithms, graph algorithms, advanced sorting, and searching techniques. These concepts are essential for tackling challenges in computational problems and optimizing software performances. So with this, I done with my today's topic. I hope you understand about algorithms. So thank you.